Today we're going to start exploring three-dimensional solids. And while this will be the first time that we, as a class, have talked about three-dimensional solids, it's definitely not the first time you've ever seen them. I actually looked through the district's curriculum because I was curious, and the first time you started learning about three-dimensional solids was in 2nd grade. And then you learn about them, or review them, a little bit every year after that. So with this being 10th grade, you've probably learned about these figures for about 7 years in a row. So hopefully this is the easiest lesson I've ever taught you because you should definitely already be familiar with all of these shapes. However, it is really important that we review this material because where we're heading after this is calculating surface area and volume, which you've also done in the past, but not quite as complicated as what we'll be doing in this class, because now we know the Pythagorean theorem and we're just mentally more ready for more challenging problems. So let's get started. Remember that a polygon is a two-dimensional shape that is enclosed by straight lines. We talked about those right before spring break with our quadrilaterals chapter. A polygon are things like hexagons and pentagons and quadrilaterals and triangles and all of that. And they're all two-dimensional, which means you could draw them on a piece of paper. But now what we're going to be talking about are polyhedron, which are three-dimensional figures. And in order for it to be considered a polyhedron, it has to be enclosed in polygons. If it's made out of things with circles, like a sphere, for example, those actually aren't considered polyhedron. They're just considered three-dimensional solids. But no matter which category they fall into, we're going to learn how to identify them and calculate their surface area and their volume, regardless of whether they're just a three-dimensional solid or an actual specific polyhedron. Every polyhedron has faces, and faces are just another way of saying sides. So if you look at this rectangular prism that we have on the screen right now, it has 1, 2, 3, 4, 5, 6 faces. I kind of think about this like a Kleenex box. You probably have one handy. If you pick it up and look at it, you can count that there are 6 different sides, or faces, to that shape. Each of the lines that connects each face is called an edge. So each of these straight lines, whether they're dotted or solid, each of those is considered an edge. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. If you don't believe me, go pick up that Kleenex box again and count how many edges there are. And you'll notice on the digital diagram there's dotted lines, and that implies that you can't actually see those edges. Like if you look at that Kleenex box, you can't actually see all of the edges all at the same time, so we represent that with dotted lines when we make digital diagrams. And then the vertices are where each of the edges meet. So this, for example, this little corner is a vertex. And there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices on this rectangular prism, or on this Kleenex box. Now remember, in order for it to be a polyhedron, a special type of three-dimensional solid, it has to be enclosed in polygons. So what I want us to do on those next few examples is identify, is it a polyhedron or not? And if it is a polyhedron, tell me how many faces, edges, and vertices it has. If it's not a polyhedron, tell me why. So looking at this first example, I see some triangles and some rectangles, and those are both examples of polygons, so since this shape is created out of polygons, it is a polyhedron. So let's count the faces, edges, and vertices. There are 2 triangular faces, and there are 3 rectangular faces that wrap around. That's a total of 5 faces. There are 3 edges per triangle, so that's a total of 6. And then there's 3 edges that connect each of those triangles, so 3 and 6 gives me a total of 9 edges. And there are 3 vertices on each of my triangles, and that's all the vertices I see, so there are a total of 6 vertices on this polyhedron. What do you think about our next example? Is it a polyhedron? No, it's not. And the reason is because it has curves. Polygons have straight sides. So since this shape isn't made exclusively from polygons, it is just considered a three-dimensional solid, not a polyhedron. What about our last example? Is it a polyhedron? Yeah, it is, because it's created from triangles and a hexagon. And those are all polygons, so that means that this is a polyhedron. So let's count how many faces there are. We have this hexagonal base, so that's one face. And then from each of the sides of that hexagon, there is a triangle that comes up off of it. So that's a total of 6 triangles, 1 hexagon, in other words, a total of 7 faces. Now let's count the edges. There are 6 edges on the hexagonal base, because hexagons have 6 sides. And then from each edge on the base, there's a triangle that comes up out of it. So counting the number of edges I see on those triangles, I see 1, 2, 3, 4, 5, 6 edges. So I have 6 and 6 for a total of 12 edges. For the vertices, there are 6 vertices on the hexagon, and then the triangles all meet together at one vertex at the top. That's actually called the apex, by the way. So there are a total of 7 vertices. We can classify solids into 3 main categories. Either they're a prism, or a pyramid, or a sphere. Let's talk about prisms first. A solid is a prism if it has 2 congruent bases. There is a special kind of prism, which is called a cylinder. Cylinders are unique because they have circular bases. But typically all of our other prisms we will just classify by what shape the base is. So this would be an example of a rectangular prism because its bases are rectangles, and this would be an example of a triangular prism because its bases are triangles. In order to identify which of the faces on a prism are the bases, you have to look for the shapes that are parallel and the same shape. You can also look for the sides of the prism because the sides will always be rectangles. No matter what shape your base is, the sides that connect the 2 bases will always be rectangles. So looking back at these examples, this is a triangular prism because these 2 triangles are the same shape and they're parallel to each other. And the faces that connect these 2 bases are all rectangles. Now on this example, our rectangular prism, since all of the faces are rectangles, you can actually choose any pair of parallel sides to be considered the bases. So you could consider the rectangle that it sits on and then the top rectangle to be the bases if you want to. You can consider the front and the back to be the bases if you want to. No matter which pair you pick though, they have to be parallel and the same shape. So that's why when we look at the cylinder, its bases are circles because they're the same shape and they are parallel. Cylinders are somewhat unique though because instead of having multiple rectangles that enclose the bases, there's just one big rectangle that curves around the shape. Like if you were to cut this and unfold it, like if you imagine taking a soda can and chopping the top and bottom off, so you just have the smooth part that goes around, if you were to unroll that, it would actually be a rectangle. So it still holds up to what we said on this slide, that the sides of a prism connect the 2 bases and that the side has to be a rectangle. The side of the cylinder that's not the bases is also a rectangle. It just happens to be curved. Now let's talk about pyramids. Pyramids have 1 base. And if that base happens to be a circle, then it's called a cone. So looking at each of these 3 examples, they each only have 1 base. This one has a base that is a quadrilateral, this one has a base that is a hexagon, and this one has a base that is a circle. And since they each only have 1 base, that makes them a pyramid. And the other faces are triangles. And those triangles will always meet together at what's called the apex, which is a single point above the base. The exception being cones. Cones are not created from a triangle, it's actually a sector. We'll look at that later this week, but if you were to unravel this cone, it would actually be a sector of a circle that you're looking at. And then our last category of 3D solids is a sphere. A sphere is a set of points in a 3-dimensional space that are all equidistant from a center point. So basically what we have are prisms, which have 2 bases, and their bases are connected by rectangles. and pyramids, which have one base, and the other faces are triangles that meet together at the same point. And we have spheres, which are a set of points that are equidistant from a center point. So let's look at a few examples and identify what kind of shape it is that we're looking at. The first question you should really be asking yourself is, how many bases are there? Is there one, is there two, or is there none? And in this case, there are two bases. I see two right triangles. They're the same shape, and they're parallel to each other. The other faces of this shape are all rectangles. None of them are parallel to each other, which means they can't be the base. The base has to be the triangles. So that means this would be classified as a triangular prism. Our next example has only one base, and that base happens to be a circle. So since it has one circular base, and the other face is a sector that wraps around that circle and meets at one point called the apex, this is considered a cone. It might look like our next example only has one base, but keep in mind that sometimes a shape will be drawn in such a way that you can't see all of it, like this one. This is technically a cylinder. It has two parallel faces, which are both circles, and then the other face is a rectangle that wraps around those two circles. So even though it's not drawn on the diagram with like a dotted curve or something over here, you are to assume that there is another base over here, so this would be considered a cylinder. How many bases do you see on this shape? I just see one. This triangle up top is the only base that there is, and it's in the shape of a triangle. So since it has one base that is a triangle, it must be a triangular pyramid. And that's all you need to know about identifying three-dimensional solids. Next up, I'm going to have you watch a couple of videos from people who can explain with visual software a little bit better than I can of what a cross-section is, and then also what a solid of revolution is. After that, we'll move on to calculating the surface area and volume of these three-dimensional solids.